Assalamualaikum everyone, we are from group 6 consisting of Kalisa, Izam, Putri and myself Hasmi. So in this video, we are going to present our project on the production of bioplastic from banana peel waste. As we all know, plastic pollution has become a serious issue nowadays because most conventional plastic are non-biodegradable and take a very long time to decompose. Because of this, there is a growing need for more sustainable alternatives such as bioplastic. Bioplastic can be produced from natural and renewable resources, including food waste. For our project, we choose banana peels because they contain natural starch which is suitable for producing biodegradable plastic. So the main objective of our study is to produce bioplastic from banana peel and to study the effect of glycerin on the flexibility of the bioplastic. Now, I will pass the presentation to my teammate to continue with the methodology.
My name is Putri Munaira binti Imirham. I will present the methodology of our experiment on producing bioplastic from banana peel waste. First, materials we use are banana peels, distilled water, gelatin, gum tragacan, and glycerin. Next, the apparatus we use are blender, electronic scale, mesh strainer, teaspoon, and multi-cooker. Now for the process of bioplastic for each sample. First, we wash, cut and dried the banana peels. Then we blended 40 grams of banana peels with 30 milliliters of water until smooth. After that, we heated 200 milliliters of water and added gelatin, gum tragacan while stirring. Next, we added the banana mixture and different amounts of glycerin. For sample 1, we added 1 teaspoon of glycerin, 2 teaspoons of glycerin for sample 2, and 3 teaspoons of glycerin for sample 3. Then we filtered the mixture and poured it into a tray. Finally, we left it to dry for 3 days to form bioplastic. After the bioplastic was ready and became plastic, we tested it using several methods. First, the burning test was carried out to measure how long it takes for the bioplastic to burn or decompose. Next, the flexibility test was done to determine how flexible the bioplastic is. Lastly, the water absorption test was conducted to see how much water the bioplastic can absorb. That's all from me. Thank you.
Moving to our results, we successfully developed 3 distinct bioplastic films by varying the glycerin concentration. Our data clearly demonstrate that glycerin acts as a powerful plasticizer. The higher the glycerin content, the more flexible and soft the resulting film became. Conversely, lower concentration lead a harder, less flexible material. We put these samples through 4 rigorous tests. In the flexibility test, sample 3 with the highest glycerin achieved a full 180-degree bending angle, while sample 1 was the most rigid at 120 degrees. This trend continued in our tensile strength analysis, where sample 3 showed the greatest elongation at 0.5 cm. However, there is a trade-off. Higher glycerin also led to increased water absorption due to its hydrophilic nature and a faster burning rate. Interestingly, sample 1 proved to be the most flame resistant, taking nearly 3 seconds to burn compared to sample 3's rapid 1.25 seconds. Based on this interaction, we've identified that moderate glycerin concentration provides the best mix, balancing durability with the necessary flexibility. Ultimately, this result proved that banana peel waste is viable, starch-rich raw material for sustainable innovation, directly supporting SDG 12 and 14 by turning food waste into a solution for oceans.
Next, we move on to discussion part. So first of all, for the flexibility, higher glycerin increase the flexibility of the plastic because the glycerin acts as plasticizer. And then secondly, for the burn rate, higher glycerin burn faster due to higher flammability. And then for the water absorption, higher glycerin increase the water absorption because the glycerin has the properties of hydrophilics. And then lastly, the best mix of our bioplastic is the moderate glycerin because it gives balance strength and flexibility. And then for the SDG impacts, we apply 4 types of SDG impacts in our bioplastic project. So first, SDG 9, industry innovation and infrastructure. So innovation in sustainable bioplastic production will help decrease the environmental problem. And then secondly, SDG 12, responsible consumption and production, which is we turning the food waste into useful materials. For example, this very own project, biodegradable plastic. And then thirdly, SDG 13, climate action, and SDG 14, life below water, having the same impacts on our life, which is reducing environmental impact of plastic.
So for the conclusion of our project, we found that banana peel waste has good potential to be used in producing biodegradable bioplastic. We also observed that glycerin plays an important role in influencing the properties of the bioplastic. With a higher amount of glycerin, the bioplastic becomes more flexible, but at the same time, it tends to absorb more water and burn faster. Therefore, a moderate amount of glycerin provides the best balance between flexibility and strength. Overall, this project shows that food waste such as banana peels can be transformed into a useful and environmentally friendly material, which helps in reducing plastic pollution. That's all from us. Thank you.